With parallel and perpendicular lines, we always want to look to the slopes to help us make comparisons and give us information about the different types. So when we first look at these examples at the beginning, we see here line 1 and line 2 are parallel and they have the same slope. Remember, M means slope. Over here, we have two lines that meet at 90 degrees, so they are perpendicular to each other. So when you multiply the slopes of these two lines together, you'll always end up with a number of -1. That's just a little hint there. And the symbol for perpendicular is kind of like a T upside down. Basically what they're showing you is the perpendicular lines being drawn. So when you see that, that means perpendicular. All right, so let's have a look down here. In each example, we're given two slopes, and we're asked to determine if the lines are parallel, perpendicular, or neither. So when we have a slope of 2/3 and we have a slope of 3/2, they're reciprocals, they're flipped, but they have to be negative reciprocals. So one of them would have to be the opposite sign of the other. Since that's not happening, they're neither. They're not the same, 2/3 and 2/3, or 3/2 and 3/2, and they're not negative reciprocals, so they're neither. In the next question, we've got a slope of 1/2 and we've got a slope of 3/6. But remember, we can reduce that fraction by dividing by 3, so we can see the slopes are the same, so they're parallel. Down here, we've got a slope of -3 and a slope of 1/3. -3 is the same as -3/1. So if we flip it and multiply by -1, we'd get 1/3. So these two slopes are negative reciprocals. Therefore, these lines are perpendicular. Perpendicular. There we go. For D, we've got a slope of 4/3. If we were to flip it, we'd have 3/4, and then multiply by -1, we would get the same as this slope here. So these two slopes are from lines that are perpendicular to each other. Here we've got a slope of 2/5. Here we've got a slope of -2/5. So they are negative to each other, but they're not reciprocals, so they're neither. And they're obviously not the same because this one has a negative sign. Without the negative, they both would have been positive. They both would have been parallel to each other. This last one has a typo. It's supposed to be 0.6. So its slope is 0.6. This one has a slope of 3/5. But if you were to turn this fraction into a decimal, you would find 3 divided by 5 on your calculator would give you 0.6. So they actually have the same slope, so they're parallel. All right, now in the next question, it asks us to determine if the lines are parallel, perpendicular, or neither. So we've got this line that's going through the point A and B. A is at 3 and 2, and B is at 6 and 4. So right there. So we've got this line here, and then we've got another line, C and D, that we could draw at -8 and -2 somewhere there, and -2 and 2 somewhere there. So they're asking us to determine if the lines are going to be parallel, perpendicular, or neither. Well, sometimes you get asked to prove things algebraically, and that means you have to use algebra to show it. You can't just draw a picture, a diagram like I did here. That's geometrically. So if we're going to prove it algebraically, we need to find the two slopes and then see, like we did up here, are they the same or are they negative reciprocals or neither? So let's find these two slopes. First of all, the slope of A and B, we can find their slope by using the formula slope equals y2 minus y1, the change in y values, over the change in x values. We'll label our points. The first x point and y point, the second x point and y point. Oh, and look, that should be y2. Does it matter if we call this one x2 and y2 and we call this x1, y1? No, it doesn't matter. You just have to make sure that if this is a 1 here, this is a 1. So pairs have to go together. If this is a 2, this one cannot be a 1. It would have to be a 2. All right, so let's figure it out. y2 minus y1 is 4 minus 2 over x2 minus x1, 6 minus 3. That gives us 2 over 3. So the slope of AB is 2 over 3. You go up 2 and over 3. So if these two lines are parallel, the slope from these two will give us 2 over 3. If they're perpendicular, we'll have negative 3 over 2. So let's see what we get. I'm going to label them x1, y1, x2, and y2. Our formula is y2 minus y1 over x2 minus x1. So y2 is 2 minus 2. Notice we've got the minus here and the minus here. So we've got two minuses together. x2 minus x1. x1 is negative 8. So 2 minus minus 2 means plus. So we've got 4. 2 plus 2 is 4. And then negative 2 plus 8 would give us 6. Now we need to reduce that fraction. So we divide each by 2. And we would get 2 over 3. So this one has a slope of 2 over 3. They have the same slope, so therefore the lines are parallel because they have the same slopes. Okay, let's move on. This question says graph the following lines, find their slopes, and determine if the lines are parallel, perpendicular, or neither. So this equation here is y equals x plus 1, and they ask us to graph it. You can graph a line a couple of different ways. You can graph using a table of values where you choose some x values and then you find out what y is. So if x was negative 1, for example, y would be negative 1 plus 1, which would give us 0. If x was 0, y would be 0 plus 1, which would give us 1. If x is 1, y would be 1 plus 1, which would give us 2. So we could put these points on and graph it this way. 0 and 1 and 1 and 2. All right. Then we join those points with a straight line and we'd have our line drawn. Now another way that you can graph it would be to start with the y-intercept. Right here, this value 1 tells us that the line is going to cross the y-axis at the point 1. Then we would look at the slope. So the slope is 1. You don't see a number in front of x, so it's a 1 there. So the slope is 1, rise of 1, run of 1. M equals 1 over 1. So we could start here with the y-intercept of b being 1, count up 1, and over 1, we get to that point. Count up 1, and over 1, we'd go here, up 1 and over 1. So if we did that, we could plot our points just by counting from the y-intercept, get a few points, join them with a ruler. So those are two different ways, table of values or finding the y-intercept, finding the slope, and counting up and over using the slope. All right, now the second line over here is 4x plus 4y plus 8 equals 0. So this equation here is not in slope-intercept form. So right now we can't see what the slope is and we can't see what the y-intercept is. So we could graph it using a table of values. We could pick some x values and some y values, pick some x values, substitute them in and find out what y is. So if we picked x was 0 and we did some algebra and subbed in, we'd find that y is negative 2. If x is 2, y is a negative 4. If x is 4, y is a negative 6. So we could plot those points on. What we could also do, if we wanted to graph it a different way, we could take this equation and we could use our algebra skills and rearrange it into y equals mx plus b form. Then we would know what the slope is and we would know what the y-intercept is. We could go to the graph, start at the y-intercept, and use the slope to count up and over. So let's rearrange our equation. We would need to subtract 4x from this side and 8 from this side. So we would get 4y equals negative 4x minus 8. Then to get y by itself, so it's in y equals mx plus b form, we would divide by 4 here. We would divide negative 4x by 4 to get negative 1x. We divide negative 8 by 4 to get negative 2. So this equation has a slope of -1 over 1, and it has a y-intercept of -2. So if we go over to the graph and look at -2 as our y-intercept, and then our slope is -1, so we'll count down 1 and over 1. Then we count down 1 and over 1 again, and we can keep doing that till we have a bunch of points here. We join them with a ruler. And we have graphed the lines. And really we should label them. So this is for y equals, what do we get here? Y equals -x minus 2. And this one was y equals x plus 1. So the question asked us to determine if the lines were parallel, perpendicular, or neither. Well, when we look at it, they look like they're perpendicular at 90 degrees to each other, but we actually have to look at the slopes to be certain. So this one has a slope of 1 over 1. This one has a slope of -1 over 1. So if we flipped this slope, well, it would be 1 over -1. And if we multiplied it by -1, we would get this slope here. So they actually are perpendicular. The slopes are negative reciprocals, and you can see that when you look at the graph. They're at a right angle or 90 degrees. All right, the next question is asking us to tell if the lines are parallel, perpendicular, or neither. So once again, we have to find out what the slope is. This question, or this equation, already has our slope right here. M equals -2 over 3. So what we need to do is look at the other equation and find out what its slope is. So I can rearrange this equation. I'll subtract 3x from the left side, and I'll subtract 12 from the left side to get -3x minus 12. I'm going to divide every term by -2. And what I get is y equals a negative divided by negative is a positive, so I have 3 over 2x. -12 divided by -2 gives me positive 6. So this equation has a slope of 3 over 2. So when we look at the two slopes, the slopes are negative reciprocals. Therefore, the lines are perpendicular. All right. And the last question here asks us to find the slope of a line that's perpendicular to another line when they give us the slope. So if we have a line that has a slope of 4, well, another way to write the number 4 is 4 over 1, 4 divided by 1. If you want a perpendicular slope, you have to flip it and multiply by -1. So that's our answer. With the next question, B, we have a slope of -3 over 8. So to find a perpendicular slope, we have to flip it and multiply by -1. So a negative times a negative would give us a positive. So we're going to have positive 8 over 3. So that's our perpendicular slope. Now over here, this is an interesting one because we have a slope that's undefined. So an undefined slope looks like this. Here's x axis, here's our y axis. An undefined slope means that the denominator is 0 because you can't divide a number by 0. So that happens when we have some sort of rise but a run of 0. We're not going to the right or to the left. So this line here has an undefined slope. This line has an undefined slope. Any vertical line has an undefined slope. So if we want to find a line that's going to be perpendicular to it, we need a line that's going to run the opposite way. It's going to be a horizontal line. So all of these orange lines, assume I've drawn with a ruler, they're all perpendicular to the red lines. So those are horizontal lines, and we know that perfectly horizontal lines have a slope of 0. So m equals 0. The equation of these lines would be something like x equals 2, or x equals negative 3, or x equals 5, or x equals negative 10. All of those equations have slopes of 0.